Yes, indeed, and we're about to unravel, or at least return, to one of our favourite mysteries over the past couple of years, and it's the topic of Cern. We're going back,
Mm,
Scott, and like I promised you, dude, we wouldn't flog Cern like the clickbaity grift it can be. No, we would only go back there when there was something significant to report. And what if I was to tell you, folks, that there's been amazing magical type science going on at CERN for the past 10 years, and they're only now actually starting to find out about it. What am I talking about? Well, if we come over here, we got this headline the other day, which like I said, I was going to keep for tonight to discuss with Scotty. And it says CERN experiment hints at a new force of nature. Now, we've
ooh.
obviously got the electromagnetic force, we've got the gravity, and we've got the strong and weak nuclear force, right? Well, now, thanks to all the data that they've been compiling, folks, they found that there's been something weird going on. And it's above a statistical anomaly, but it's not proof or evidence of anything yet. And that's really important to note, okay? But what's been going on then? And I'm not going to like get into the kind of science that's going to send people to sleep or might turn people off. It says here, scientists at the Large Hadron Collider near Geneva have spotted an unusual signal in their data that may be the first hint at a new kind of physics. It says the LHCb collaboration, one of the 4 teams at the LHC, analysed 10 years of data on how unstable particles called B mesons created momentarily in the vast machine decayed into more familiar matter such as electrons. So the mathematical framework that underpins scientists' understanding of the subatomic world is called the Standard Model of Particle Physics. And they think that pretty much accounts for everything that we know and what should take place, and they try and prove it with experiments as they go, right? Something different, something weird's been happening. And it says the results released by CERN on Tuesday suggest that something unusual is happening. The mesons are not decaying in the way that the model says they should. Instead of producing electrons and muons at the same rate, nature appears to favour the route that ends with electrons. So, to boil this down into basic stuff that you don't need a PhD to understand, Scott, because of the standard model, it should work one way, and you should see an equal amount of electrons and muons being present. But now that they've gone back and looked at all the reams of data, they've figured out, and it's beyond statistical anomaly, like I say, that more times than not, doesn't work the way the standard model predicts. Well, do you know what that tells me? You know what that tells me? Maybe the standard model isn't everything that we crack it up to be, and nature doesn't need to adhere to the rules that we've put on it, you know?
Exactly. I mean, the standard model would suggest that, you know, when there's this decay, that you would see an even spread of electrons and muons, right? But it seems to be favoring the electron route, which suggests that, you know, there's something else at play here, you know, that is causing that behavior. And so, like you said, you know, it looks like the standard model needs to be reevaluated because there's something else going on here. And I think this probably has a lot to do with like why the universe, while it's uniform on a macro scale, right? Like if you were to look at the cosmic background radiation image in its totality, it looks like white noise. It looks spread out evenly. But as you start to look at areas of space, you know, in a much more granular fashion, then you notice that there is elements of randomness and whatnot throughout the universe, obviously, because if everything was just uniform, it would just be like whatever, a solid gray soup of there wouldn't be planets or stars or anything like that. We would all just be this uniform something, right?
A soup of a
So
soupiness. That's what we would
yeah,
be.
it's
Yeah.
just a soup of the most bland soup you could
Well,
possibly imagine, because there would be no variation or difference. But obviously, when the universe came into creation, things weren't completely symmetrical. Things weren't completely evenly spread. So that's why we have galaxies and pockets of empty space and pockets of space with tons of matter in it and all of that. So I think this might play into that whole thing.
this is pretty cool, and it says here, this is a scientist now, and it says if it turns out with extra analysis of additional processes that we were able to confirm this, it would be extremely exciting. It would mean there is something wrong with the standard model and that we require something extra in our fundamental theory of particle physics to explain how this would happen. And it goes on to say, I would say that there is cautious excitement. We're intrigued because not only is this result significant, it fits the pattern of some previous results from the LHCb and other experiments worldwide. I really think this will turn into something. And it says, if the results turn out to be true, Scott, it could be explained by so far hypothetical particles called Z primes or lepto quarks that bring new forces to bear on other particles. Now, I remember when Anthony Patch predicted them finding the peta quark at Cern. And
For
about
that,
3 weeks later, whoa, Cern have detected a brand new particle. Folks, the best person I can recommend you can follow for this is Anthony Patch, okay? I fly by the
yeah,
seat of my pants. I find it riveting, interesting. I'm not knowledgeable. I just kind of know some of the stuff when it comes to the language they use. But Scott, a fifth force, perhaps new particles. This is something I discussed with Tony as well. And it fits in with our conversations about intent and the nature of reality. Because for decades they hypothesized that they would find something called the God particle. And by golly, after a whole heap of looking, they found it. And I remember saying to Anthony, could it be that if scientists believe in a hypothetical particle strongly enough, and if we look long enough, is it not a possibility that we ourselves could bring things into manifestation?
but
And Anthony Patch, he agreed. So I don't know, dude. It's weird.
it's an interesting way of looking at it, right? And I mean, we've discussed this many times on here on KBS and on Freaky Friday, right? About it's like that whole tulpa thing, right? Where you focus your intent on something in order to bring it into existence. And you got to figure, if you have like these teams of scientists that are, I mean, their life's work is to find a particle, right? And I mean, they're living and breathing and eating and drinking
Not to mention
their
the confirmation bias that must be sewing into the search for something,
yeah, I mean, it does make you wonder. I mean, you have a lot of people focused on this one particular goal, on this one thing, and not only that, and then you're throwing in the fact that they have that intent, they have that focus, and then they're surrounded by this machine, right, with huge levels of magnetic energy and all of that. And then it makes you wonder, well, then why is Shiva, a statue of Shiva out there in front? And I mean, doesn't that all kind of tie into
This is why you
intent?
can't separate. You can't separate that spiritual side from Cern, Scott, because they wear it on their sleeve with pride.
There's definitely this element to it, right? Which I that's why I got so intrigued with the way Patch was attacking this topic, right? Because he was looking at it from a very, very different perspective, I would say. And but not only that, I mean, Patch is extremely, extremely knowledgeable in the information as well. Like, he can break down the scientific papers and what they're actually doing there. And but hey, I mean, this goes back to what I was just talking about. You know, you can say you're an expert in a field, and you know, I said, well, you know, unless you have a PhD, but you're like, look, you know, even if there is a PhD, yeah, well, I mean, I'm sure right now a lot of the experts in the standard model are like, because they don't seem to be experts anymore. You know, I mean, it looks like there's going to be something.
You think we just misunderstand the electromagnetic force because we talk a lot about the electric universe? Maybe it's doing a lot more than we give it credit for. They're saying here that it's strange because the B mesons, they should break down at a rate to create bottom quarks, and everything's made up of 1 electron and 2 quarks, and that's part of it. I've looked at that quantum fields theory as well, where they say that the electrons could all exist in a field that's everywhere, omnipresent throughout the universe, but they only manifest and come into physical form where they need to, like wherever solid things are. Maybe this is hinting at that. Since only the electron seems to be the thing that holds true, maybe everything is built on that field, that quantum field, dude.
Yeah, I mean, there's obviously something that is holding all of this together at some level, right? And
it's obviously built from some fundamental ground layer up, right?
Yeah, exactly. So that's what I was just about to get at, is that it seems like the more we the smaller we go, right? Like, when we start getting into quantum and these, what is the smallest unit of measurement? What is that? The Planck scale, I believe.
Yes, it is.
Yeah. You know, when you start getting down to that level, and even, you know, it's like we're starting to hit like the base level of the code, right? It's like you're almost trying to pierce in and view the source code, if you will. And it's like there's a barrier there that we just can't quite get across. I would say an interesting way of looking at it would be like, imagine Mario, Super Mario, right, in the video game, coming to the realization first that he's in a video game, but then while Mario is in the middle, in the middle of this video game, he's managing to figure out the motherboard and hardware specs of the system that his video game is being played in, right? So if you imagine humanity as Mario, we're trying to figure out the hardware
that's running this place.
Yeah, the hardware that's running this simulation, or whatever you want to call it. So it would be like Mario coming to the realization that, you know, or trying to figure out exactly what type of microchip is in the motherboard of his Nintendo Entertainment System, right? It's like that kind of a mind-blowing thing that is occurring here. And, you know, is this information that we're meant to know? I mean, there's obviously, like, I would say firewalls or inherent blocks built into the system to keep us from figuring all of this out. And
you would hope.
You would hope. you would hope. I mean, what? But is that the goal of the simulation? Is for us to figure out that we're in a simulation?
No, it's to be here and have a laugh and enjoy it, man, and enjoy it, and ask
Oh,
these questions
yeah.
at least once a night when KBS is on or Freaky Friday. There you go. But listen, something like
Uh,
this excites me, right? 'Cause when I was reading this, I took notes when because Cern had come
mm,
up, man. I was diving back into my Cern. It was awesome, you know. And something like this, though, when science comes up against something that doesn't conform to a previously well accepted kind of theory, that excites me, right? Because having spoken to scientists like Brian Keating and Brendan Drackler, that encourages me that these scientists are already what we would call thinking outside the box, especially the younger ones, because they've got their own careers to make and they're not going to do it repeating and parroting the stuff that's come before. So when you find
yeah.
something like this, we talked about Star Trek, right? We've been watching Star Trek and things like that, and you look at warp drive technology, you look at teleportation. When I was watching the other night, had somebody trialing out quantum teleportation where you'd be beaming over light years of distance. But my point being, it's when you come up against these kind of obstacles and they have to look at something from another angle, where we might be on the verge of opening up another branch of physics, another wonderful discovery. Like back in the early 1900s when people started to talk about the Copenhagen kind of quantum mechanical model, and then you had all the different kind of ideas. And we're on the cusp of this new science. And I said it to, I think it might have been last night to Lon Strickler. I see science like the light spectrum, Scotty. Much like the light spectrum, we only see a slither, right? But doesn't mean the
Yeah.
rest isn't there, doesn't exist. And science for me is the same. Speed of light, yeah, so far we're restricted to that, but does it mean that you can't travel faster? I wouldn't say so. I'd just say we need to know more. We need to know how to work with the fabric of the universe. Oh, maybe the quantum fields that we're now getting into. See?
Yeah.
Exciting. See?
Yeah. It also makes me wonder, I wonder how many times you've had like these young sort of up and coming scientists or whatever, thinking outside the box, or maybe have thought of a new way of like a new branch of science, or maybe figuring out that one certain way wasn't correct or whatever. You got to wonder how many of these guys were out there that were thinking about some of these kind of groundbreaking things, but then they ended up like not wanting to rock the boat of the established scientific consensus or dogma at the time, and never really did anything with it, right?
We're looking at
it's
how corrupt science is, thanks to Kevin
yeah,
McCairn. It must be really easy just to go along with the group and get funding, get tenure. As long as you don't rock that boat, it must be really easy to take that option, you know?
yeah, because I mean, I'm sure there have been guys out there that have figured something out that was like a paradigm shifting sort of breakthrough, but the implications that it could have, like, you got to wonder if they were like, maybe it's just not worth it.
You mean like potential Teslas of our time?
Yeah,
Yeah.
that's
The ones we haven't heard about, you know?
Yep.
Yeah.
Yep. Or they end up getting recruited into their talents are exploited. That there's
Powers
that
that
as well.
shouldn't be get them. Oh no, no, no. But the LHC, don't panic, folks. There ain't a portal opening anytime soon. Well, maybe we're going to get into portals after the break, and we're going to get into coincidences because we don't do coinky dinkies here. But one last thing about CERN before we go. They're obviously going through their big upgrades, the long shutdown too, right now. So when they do fire it up again, it's going to be a little different because it's going to be high luminosity and that means more smashing of particles. And I was reading today, Scott, the way they do it is pretty cool, right? Because just at the last moment, so far, you're talking about bunches of billions of particles trying to hit each other head on, which is pretty hit or a miss. But now they've come up with a way for one of the streams at the last moment to kind of rotate the way that it's going. Does a little flip so that there's more probabilities of collisions when the two streams come together. They call it a crab-like flipping, and they kind of smash in, and it's just so much more efficient, so much more woo, so much more power. And if you were worried about Cern before, oh boy, oh boy, oh boy, oh boy, you got a lot to worry about around the corner. No, but it's going to get exciting. It's kind of cool, the physics they're doing. My point, Scotty, you know?
Every time we talk about CERN or particle accelerators, I still think of that story of the Russian guy that stuck his head in a particle accelerator when it activated.
Not a good day.
That was a very, let's just say the side effects from that he had to deal with afterwards were very, very interesting.
The one I was watching on Star Trek last night makes me think of this because the guy had tried to teleport, Scott, and for some reason his signal hadn't been put back together, and he was in a state of like quantum flux. So he was just he was there, but he wasn't. And dude.
See, he got eldridged. That's what happened.
He did, dude. He did. But you think the particle accelerators, though, there must be one part of it, right? There must be a team in there that are working on what, like the kind of thing we're talking about here. Time travel, teleportation, all the woo shit, right? Oh, pardon me.
I'm going to go out on a limb here and say that maybe Gene Roddenberry, maybe the whole teleporter thing was maybe influenced by the whole Philadelphia experiment thing.
Oh boy, oh boy. And when we come back after the break, we're going to be talking about the kind of thing that might have opened up around the Eldridge portals, ladies and gentlemen. Yes, scientists telling us that these portals, don't worry, it's not that they can't happen, they might always be happening. Oh boy, oh boy, oh boy. Yes, indeed. So that's to come. We're also going to get into Coinky Dinkies. And don't forget, folks, if CERN doesn't concern you, there's always that bigger one that they're building in China. 100 kilometers radius. Oh boy, oh boy. Diameter, circumference, circles always confuse me. We'll be back after the break with more of Kev's not so sacred geometry.